Here we are in our Excel worksheet. If you have access to the Excel worksheet and would like to follow along, note that we are in the Practice tab as opposed to the Example tab. The Example tab, in essence, being an answer key. We have the information on the left-hand side. We're going to put that information into the blue area on the right-hand side, doing a few different calculations, including a mathematical calculation, kind of a running balance type of calculation, present value of an annuity function or formula type of calculation, and then we'll use the tables. Going back to the information on the left, a little bit different. We have an annuity type of formula, but a little bit different scenario. We're going to use that formula to back into, in essence, the rate. So we have an investment. We can imagine that an investment's going to be put in possibly for retirement or something like that of the $60,000. And we imagine that the company, the financial institution, then saying, okay, well, we will then give you payments, annuity payments of that, of $5,500 for 20 years. So once again, we the individual imagining we put in $60,000 and say I would like to set up an annuity to be paid some fixed amount per period, and they say, okay, we're going to give you the $5,500 per period for 20 years based on that investment. So then the question is, okay, they didn't give me the interest rate here, but they gave me everything else, so I can kind of back into the rate using our formula down below. A couple ways we can do this. We can do this algebraically by basically looking for the unknown, which in this case would be the rate. So here would be our formula. The end result of this formula we know is going to be 60,000. So algebraically we can set up an equation saying 60,000 equals P. P is going to be the 5,500. 1 minus 1 plus R. R is the unknown to the negative n, that being 20, the time period, divided by R, the unknown. Therefore, we then solve for R given the fact that we have one unknown in our algebraic equation. That's one way we could do it. This is kind of we're starting to get like a longer type of equation to run the algebra, and we might just say, hey, I'd really rather do it just with Excel or something like that. In practice, obviously in a book problem, you'll probably have to do the algebra, but in practice, you might say, hey, can't I just use like a formula to do that, because I know what the present value of an annuity formula is, and R is in that function. Is there some way I can basically make Excel to use that function and back into the R format? So if I go, for example, over to our annuity, which we're going to do over here, and use our formula, this equals the present value of an annuity type of formula. Here's the rate, number of payments, and then the number of periods and the payment. If there's one component that is unknown, is there some way I can use the same formula instead of looking for another formula, such as one that would be solving for the rate here, and use it algebraically in a similar fashion given the fact that I have one unknown? We can use the goal-seek, basically trial and error type of method in order to do that, and so we'll practice with that as well. So I'm going to go back to the left. And so first, we can solve this algebraically, plugging this into the formula, solving for R. Now I'm going to do that formula up top, writing it in our table type of format as we have seen in the past, this being a precursor to the way we will do it basically with the actual function in Excel. We'll kind of do this trial and error and use the goal-seek method. Okay, so we know that the payment is going to be the 5,500. We're going to have in the outer column this times this. In the inner column, we're going to have this calculation, and then we'll bring the numerator over into column E. So there's the 5,005. We're then going to say that we're going to have 1. I'm on the numerator now. I'll bring this into the inner column. Now we got the 1 plus R to the negative n. So 1 plus R, which is going to be the unknown. So I don't like to just keep the unknown as 0. I'm going to plug in something for the unknown, so it will then calculate even if you have a situation where you're dividing by 0 or something like that. Otherwise, it's going to be more difficult to use the function. So I'm going to say, let's just plug in a number for R, 0.05 I'm going to put in. I'm going to percentify it, Home tab, numbers, percentify it. I'm going to make it yellow so we can see that that is what we're really looking for. And I'm going to underline that tab. Then we'll have the subtotal equaling the sum of these two items. And we will percentify that, Home tab, number, percentify that. So there's the 105. Let's add a couple. Actually, that's good. We may need to add some decimals when we find the rate here. And then we're going to take it to the negative n. So I'm going to say negative 20 negative 20, that being the number of periods. I'm going to underline that. Home tab font group underline. We'll bring this out into the outer column. Now having calculated this component, this is going to be equal to the 105 shift 6 caret negative 20 number of periods. Let's add some decimals. Home tab numbers, decimalize it, and then home tab font and underline it. We'll do our subtraction to get the numerator here. So this is going to be 1 minus that thing we just came up with, and then we'll add some decimals. Again, home tab numbers, decimalize. So there we have that. And then we have the whole numerator. Let's do the denominator now, which is going to be, once again, the unknown of r. I'm going to say equal to that 5% so that I can use that 15% as the changing factor and have it all connected out instead of hard coding it down here so everything's tied together. And then I'm going to go to the home tab, font and underline. Let's bring this into the outer column. We have the numerator and denominator as of one numbers now. So let's go ahead and take the numerator and divide by denominator. And then let's add some decimals. Home tab numbers, decimalize, underline, home tab font underline. And then we'll go ahead and multiply this out. So we're going to say this is going to be equal to the 5,005 times that whole thing that we just did right there. Add a couple decimals possibly. Home tab numbers, couple decimals. So now we can see that we can use then our trial and error method basically to figure the rate here. So I'm going to change the rate and say, okay, I know what the end result needs to be. This end result needs to be the 60,000. I'm at something greater than 60,000. So what if I change this rate to like 6%? Then I'm getting close, right? What if I change it to 7%? Then I went too far, and so on. And we can of course use goal seek to figure that equation out. So now let's use goal seek and say, hey, Excel, would you be kind enough to do this work for us and figure it out? And Excel's like, yeah. How? And Excel says, well, you got to go over to the data area and then to the forecasts and the what if analysis, and then use that goal seek, seeking the goal. And the goal is going to be that we want that number to be 60,000. That's the goal. It's a noble goal. And we want to do that by changing this cell right here. Change that cell to make that cell 60,000. We're going to say okay, and it does it for us automatically. So I'm going to close that out and then go to the home tab here, add a couple decimals, and I'll add a couple decimals down here. So there we have it. Now, again, if you have the algebra, you can of course do the algebra to solve for R and not have to do this kind of method. But if you're using a function, then it's useful to do this. And you can see what we basically did. We kept the same format as we normally calculate, as we normally know the function, and then basically used trial and error so that we can then find whatever unknown is going to be there. So we're kind of using the algebra, but we're using, trial and error method to kind of back into the number as opposed to reformatting, restructuring the equation. That makes it a lot easier for us, and we can take that same concept and apply it out to the function, which is something we would most likely use in practice. Meaning, if I had this data, I'd say, well, I know I can use the present value of an annuity function here, and I'd like to use it and have the unknown be the rate. So, but obviously when I use the function, the end result is typically going to be this number within the function. So therefore, I'm going to use the same trial and error method, same kind of concept, knowing that it's not an equation, but it's a function that utilizes components of data. And if I only have one component of the data, which is unknown, I should be able to back into that number without needing, say, another function. I don't need to go search around for a function that would solve for the interest rate of an annuity when I know this one. So I'll do the same thing. I'm going to say the unknown I want to put in a separate box down here, and I'm going to put 0.05 starting with that 5% again, so that when I put it into the annuity, I can point the annuity to this item, which is the thing that we will then vary as we search for the result that we want to find. So I'm going to do the same thing here. This is going to be present value. We're going to say this equals the present value of an annuity. We'll take the rate, that's the unknown. I'm just going to pick a rate here. I don't want to put like 0 in the rate because I want something in there in case there's some kind of thing where it gives me an error message, like dividing by 0 or something like that. Comma, number of periods is going to be the 20 that we have over here. and then comma, and then we've got the payment, which is the 5,005. Now, the end result of this we want to be the 60,000. It's not going to be 60,000 because we don't know what the rate really should be. We just guessed. So I'm going to say enter. So it's something different. I'm going to double click on this. I'm going to put a negative sign before the P to flip the sign to make it a positive number. And now we can do our trial and error. I could say, okay, now I just need to make this interest rate, whatever it is, to get to that number to be 60,000. So I could say, well, let me try like 8 or something like that, and so on, different rates. We can use GoalSeek to then figure that out and say, GoalSeek, Excel, could you do that process for us? Because it's kind of tedious. And Excel's like, yeah. So we can go over, the way you do it is you go over to the Data tab, Forecast, What If Analysis, GoalSeek, seeking the goal. What goal do you seek? And we want to set that cell to be 60,000. That's a noble quest. And we want to do that by changing this cell. Okay, so then we're going to say okay. And there it is, done again another way. So this is probably what you would typically kind of do in practice. This would be the easiest thing really to do in practice oftentimes. And then we're going to say, well, let's do our running balance calculation and see how that would work. Now, this is probably not something you would do necessarily to figure out this particular problem, but it shows how even if you have a complex web of things, if they're all connected, you can use, once again, this GoalSeek tool. So let's have our series of payments. We'll break this annuity of 20 periods out into the present value of 1, 20 present value of 1 calculation. So I'm going to say 1, 2, and so on. Select those items and autofill down 20 periods. And then we're going to center that, Home tab, Alignment, and center it. The payment is going to be then this 5,500. The thing we do not know is going to be the rate. So I'll do the same thing here. I'm just going to go down here and say rate. Let's make the rate like 4%. That's our pretend rate. Let's make it 0.04 this time, just to switch things up again. And then we're going to go up top, and I'm going to say, now we're going to do the present value kind of running balance as we've seen in the past using that estimated rate. So I'm going to say this is going to be equal to the present value. And we'll take then like this present value of the rate. This is what we guessed, right? We're just going to guess 4%. And then comma, number of periods is going to be 1, because we're just talking 1 of the 20 periods, 1 as opposed to 20, comma. The payment is going to be not used because this is not an annuity, but rather present value of 1, because we're going to have 20 present value of 1s instead of the annuity for 20 periods. And there we have it. I'm going to then double click on this one, put a negative before that, and then that's going to be the end value for the first one. And then let's do it one more time. I'm going to say this equals the payment. The payment stays the same. Present value calculation, I'm going to say negative instead of equal this time so that it'll flip the sign for us. Present value, shift 9, rate. We're going to pick up this 4% down here, comma, number of periods now at 2, comma, comma, because we're not going to do the payment. We're going to do the future value, which is the 5,500, and enter. There we have that. So it's, of course, a little bit smaller than the last one because this is the same payment, but 2 years out as opposed to 1 year out. Let's go ahead and say now we had the last amount we had plus the current amount that's going to be present valued back. This is where we stand in terms of present value after 2 periods. We can then copy this all the way down using our autofill. However, we need to then make an absolute reference of this interest rate, because if we do not, it will then, the related cells will go down as we go down, and we want it not to do that. So that cell right there, which is in J23, needs to have an absolute reference. We need to absolutize J23. So there's J23. We're going to put our cursor in it, select F4, absolutizing it by putting a $sign before the J, $sign before the 23. You only need a mixed reference, but absolute reference works, and it's easier for me. So I'm going to select these 3 then, and then go on the autofill handle, left click on it, drag it on down, not even going to test it. We're going to live dangerous. And then we're going to say, okay. And then this last thing, we want that to be 60,000. It's not. Now, it could be because I messed up something in the table, but I don't think so. I think we did it right. Or it just means that we need to change this interest rate. So now we can do the same thing and kind of solve for this interest rate. And if I say like 5%, now it's getting closer, and so on and so forth. Notice that this whole thing is a pretty complex web of calculations, and it's all tied together. So this one changing of this interest rate will change the whole thing. And if I want this last number down here to be a particular number, the goal that we seek is to make that 60,000. We should be able to do that by changing this one because it's all like connected together. So let's do that again. So Excel, could you make that 60,000 by trial and error? Excel says yes. Says you got to go to the data tab. Just go to my data tab up here. And then if you go to my forecast section, I have this thing called what if analysis and then goal seek, where you can enter the goal which you seek, and then we'll give it to you. So we're going to set then this cell. We want to set that cell to be the value. The goal that we seek is to set that cell to be 60,000. 60,000. And we want to do that by changing this cell. Could you do that, Excel? As you wish, says Excel. And then it does it. So there's the 60,000. So I'm going to say okay. And once again, we're at that 6.63 again. So let's take a look at it one more time with the tables, just to get a feel for the tables. It's another thing we probably wouldn't use the tables for, but it gives you a good understanding kind of how the tables work if you back into the tables and whatnot. So the amount, we know the amount, that's going to be the 5,005, and then the amount, the future value, and we actually know that too. That's the 60,000. So we actually know what the amount from the table should be, which should be the 60,000 over the 5,005. Adding a couple decimals, home tab, let's add like 4 decimals. So it should be 10.9091. So we need to go find that on the table then at what we know, which is the number of periods, 20 periods. Now it's not going to be exact because we have an interest rate that's not exact, and that's one of the downfalls or defaults of the table, but we can get an approximation of it. So we're going to say that we need the 10.9091 20 periods. So we don't know the rate. We know there's 20 periods down here, 20 periods. So there's 20. And then we need it to be 10.909. I forgot what it was, but I think it's between these two. So we could see that it's between those two, which is between 7 and 8%. So we can kind of say, all right, well, per the table, it's between 7 and 8. That can't be right. 10.9091. 20 periods. 20. 10. 20 periods. 10.9091 would be between these two. And that's going to be between 6 and 7. Does that make sense? Yes, between 6 and 7. 6 and 7. So you kind of approximate the percent there. If they were exact, like if this was a book problem and they had an exact percent, then you could probably find the exact percent with the tables. But of course, the tables are going to be limiting in that they require exact percentages and whatnot. So you can at least estimate the table or kind of back in and get an idea of how all these things tie together.